In this unpaid review, we have LED grow lights from that 1000 category. Spider Farmer, Maxsisun, and Mars Hydro. Sorry, Viper Spectra didn't make this review, and I'll tell you why in a bit. First though, a quick outline of this video. This is both a review and also an audit of several lights and manufacturers. I selected 4 well-known companies and asked for reports on their lights. Some bold efficiency claims. But did they have the data to back it up? I only reviewed companies with integrating sphere test reports showing the PPF. An integrating sphere captures and measures all of the photons emitted from a light source. This lets you determine brightness, efficacy, and more. Without that data, how can a seller accurately market the efficacy of their lights? Viper Spectra made some big claims. 2.9 efficiency? But when I asked for reports, they didn't have them. Mars Hydro wasn't much better, but I was able to get one. Fortunately, I got more useful data from Spider Farmer and Maxsisun. I have 2 lights from each company, a budget version as well as a premium one. Mostly we're talking about 100 watt LEDs. These are entry-level lights, great for seed starting, growing greens, or maybe a single medicinal plant. Let's start by reviewing their integrating sphere test reports. These reports are crucial for separating legitimate sellers from LED scammers, like the ones on Alibaba. First, Mars Hydro told me when their customers ask for testing reports, they will send them. I asked for one for their TS600, but they would not send me one. They did send me this 2-year-old report for the TS1000. We see the spectrum chart with far red or IR diodes. Right here, we should see a bump, but there's none. This is an older version before adding far red. Next, the total light output. We have lumens here, but growers should focus on this, the PPF, the photosynthetic photon flux in micromoles per second. That's all par photons between 400 and 700 nanometers. Down here, volts and amps. Next, the power in watts. PPF in watts, the most crucial parameters. These allow you to determine the light's efficacy. Take the PPF and divide by watts. This is the PPE, the photosynthetic photon efficacy, in micromoles per joule. So for this light, it was 2. At the time, Mars Hydro marketed the efficacy as 2.3, so they inflated it by 15%. Not cool, right? These reports show if a company is honest and legit or if they're just throwing out numbers. This single report was all I got. I found Mars Hydro difficult to work with, having no interest in correcting errors in their listings. Next is Spider Farmer, who started out saying their PPE was 2.7, but then I saw PPE 2.9. Really? Take a look at this SF1000. The PPF should be about 250. And this test report backs that up. Nowhere near 2.9 in efficacy, not even 2.7. Note that the SF4000 truly is 2.7, but not the SF1000. Part of the confusion stemmed from diode efficacy versus luminaire efficacy. The efficacy of the individual diodes is always more than the end product. There are driver losses and things like this which reduce that rating for the unit as a whole. To avoid confusion, I'm glad to see Spider Farmer has tweaked their listings to show true efficacy. Now compare this to the report on the right. This SF1000D only has a PPE of 2, much lower than the number on the sticker. So I had to point this out. Fortunately, they've corrected this. They've been more cooperative than Mars Hydro at correcting such errors. One last thing on these reports. See this PF value here? This is the power factor. Good quality LEDs will be around 0.99, but this SF1000D has a low power factor coming in at 0.69. In a commercial or industrial setting, this wouldn't be a good choice. For most home users, it's not so bad, but it's another thing to watch out for as sellers may sweep it under the rug. Finally, Maxsisun. When I contacted them, they were very forthcoming and had no problems sending me up-to-date test reports. They had recently set up their own integrating sphere for R&D and monitoring product quality. I really like the Maxsisun reports as they show even more data. These 2 pages are for a single light, the PB1000. No devoted IR diodes. On the left, you see some standard info, but not the PPF. That's where this spectrum test report comes in. Here's the total PPF. Down here's the power. And the efficacy is already calculated, as we can see the PPE right here. For the PB1000, it's 2.1 if you round it. But Maxsisun originally stated 2.7. Yeah, surprise, surprise, right? But wait, I contacted them, and in just a few days, their site was updated with accurate specs. And they went further, adding copies of their new test reports to their site for all of us to see. Maxsisun doesn't want to be deceitful, and it's hard as many competitors couldn't care less. Often, marketing is all that matters. So I have to give Maxsisun much respect for being transparent and correcting errors so quickly. But that's why we need these test reports. If you care about light output and energy efficiency, then ask to see them before buying. Now, let's look at Maxsisun's MF1000. Just a little more efficient than the previous. And there's that little bump with the addition of far red. So that's some data I collected to get you more accurate specs. But I took my own measurements too. Specifically, the PPFD over a 5-foot area. We have charts at 12 and 18 inches. That's from the diodes to the sensor. Readings were taken with my Apogee SQ520 quantum sensor. No reflective sides, so you can see exactly how the light spreads. Now let's look at these lights. First up, Spider Farmer's SF1000. I first examined it at launch, before the dimmer box. It has the highest PPE of all lights in this review, and at 100 watts, the highest PPF. It's a nice light that serves me well. I already had this revised unit from a previous video, and it has about 1600 hours of runtime, so keep that in mind when looking at my PPFD readings. The next 3 units were provided at no cost for the purpose of testing and reviewing. Next, the SF1000D. What's the D mean? Does it mean dimmer or no dimmer? No, the SF1000 uses Samsung LM301B diodes. The 1000D uses 301Ds. This budget version doesn't have the dimmer, but it also doesn't have a branded driver. So in other words, it's totally different than the SF1000. It's only 81% as efficient as the premium 1000, and the total PPF is similarly lower. The difference was clear as I took my PPFD readings. Just compare them at 12 inches. The average PPFD was only 80% compared to the SF1000. Along with the low power factor, you have a light that's just not as good. Next up, Maxsisun's PB1000. Their stripped down, no-nonsense model. An excellent entry-level price and an attractive, well-built light. Good water protection. The power factor is excellent. Both of Maxsisun's lights use Samsung 281B plus diodes. Not as efficient as the 301Bs, but still quite good. Here are my PPFD readings. Some good numbers, better than the SF1000D. There's no IR diode. That said, everything about it looks balanced and well constructed. Next is the fanciest light. The MF1000. The same diodes as the PB1000 with the added far red, and the overall efficacy is a little better. It has a reflector hood, a beefy heatsink, and daisy chain power. There's even this remote, which is how you dim the unit through the touch of a button. It has an onboard power switch, or just use the remote. These power cables, though, are not designed to withstand water, so keep that in mind. After measuring the PPFD, I saw some extra high center readings. This LED had the highest average PPFD of all the 100-watt LEDs tested. You get a more focused center reading. Let's switch to Mars Hydro. The previous lights were 100-watt units, so the logical comparison is the TS600. And this is the unit they didn't want me to show you. They had no test reports to back up the PPE 2.3 label on the product. Certainly they weren't going to supply me a sample, but I found this alternate means for acquiring a grow light. Something called add to cart? I had to estimate the efficacy based on my PPFD readings. Clearly, it's not as high as they claim. Next to the MF1000, there's only 80% as much light. Same power and distance, both have reflective hoods, but this TS600 just falls flat. The TS600 might be 1.8, but certainly no higher than 2 micromoles per joule. No wonder Mars Hydro didn't want me to test it. A low power factor too, so certainly it's not good for production environments. Finally, the TS1000. Unlike the others, this one is 150 watts, which can cause confusion if you don't pay attention. Is it brighter? Well, of course, I mean it uses 50 more watts. It might seem like cheating, but I decided to include it anyway, and I'll tell you why. True, they call it 1000, but it's also priced comparably. In fact, it costs less than the SF1000. The label states PPE 2.2. Due to the outdated test report, once again, I had to estimate the PPE compared to other known models. The TS1000 was using 46% more power, and compared to the MF1000, I saw about 46% more light. The efficacy must be similar, at least 2.1, but perhaps it's true to the label at 2.2. A big warning though, they falsely claimed it was waterproof. It's not even rated at IP65 standards. The driver block is, but the light has a weak spot. This barrel power connector. The solder points are exposed and unprotected, not waterproof. Wait, did their listing magically change overnight? I wonder what triggered them to update their graphic. Lots of details, but what's best? And how should we compare them? First, some misinformation and distractions to avoid. Mars Hydro still calls their TS600 a 600 watt light. Obviously, it's not. Don't fall for false, overstated wattages. And no, don't assume that those wattages are suitable replacements for HPS lights. The TS1000 is not a good replacement for a 1000 watt HPS. Watch out for fake efficacy specs. If a seller says 2.9 micromoles per joule, look for the total PPF and divide by the true wattage. Does it match? Maybe it does. Great! Now look for a test report to verify they aren't lying about their specs. Third-party tests are ideal, but I'll take what I can get. Don't get distracted by super high center PPFD readings. That's a marketing trick. PPFD spot readings are not a replacement for total PPF. And when you do look at PPFD readings, look for proper maps with lots of data points. Check the average PPFD. And if you compare those specs to a different light, make sure everything matches. The coverage area, the hanging height, and whether this is in a tent where there's side reflection. Even consistent coverage is ideal. So for these lights, we can compare photon distribution. Higher center numbers might be good if you don't have side reflection. Those hooded lights are nice for open benches as they reduce photon loss at the edges. But we also want bright lights too, so higher average PPFD values are always good. And of course, those total PPF values from our test reports are crucial for that comparison. Obviously at 150 watts, the Mars Hydro TS1000 wins, hands down, with the highest light output. Here's how each light stacks up. We have my real-world PPFD readings, and then the total PPF. Is it fair to compare the TS1000 though? I mean, 150 watts, no problem. I dimmed the TS1000 down to 100 watts and remeasured the PPFD. Look at how it compares to the others, even dimmed down. But maybe you're most concerned about efficacy. The more hours you intend to run your light, the more expensive your electricity, the more concerned you should be about it. In this regard, the Spider Farmer SF1000 takes the crown. With an efficacy of 2.5 micromoles per joule, you get the most par photons for each watt consumed. At the low end of the scale, we have the 1000D and the TS600. If efficacy matters to you, stay away from those two models. One thing that obviously matters is price. At the time of this review, the cheapest LED is half the price of the most expensive one. Are the more expensive lights worth it? An objective way to assess that is by comparing the cost to the light output. For bulbs at home, we have the lumens per dollar. Well, for these, it's the ppf per dollar, or micromoles per dollar. We see the difference in total par photons of each light. And there's also quite a difference in cost. By overlaying those, we see which lights give the most bang for the buck. The original SF1000 was only $140. Since then, it hasn't gotten brighter, but it has gotten more expensive. And right now, it's in the midst of a price spike. The MF1000 comes at a premium price too, considering the amount of light. And so, in that premium range, the TS1000 is the clear winner. A decent 150 watt LED that's priced lower than the 100 watt SF1000. In that budget price range, the SF1000D is not so great. The TS600 does well, but I would say the PB1000 is the clear winner considering its quality and higher light levels. There are also subjective aspects to these lights that you can't show in a graph. That's where your application and personal preference come into play. Do you want a finned heat sink for good heat dissipation? The MF1000 has you covered. The daisy chain power might sound nice, as well as that remote controller. It would cut down on cable clutter. For a multi-unit setup, that might be exactly what you want. The SF1000 is rated for the highest PPF at 100 watts. Out of all the other units, it has the highest ratio of far red light. It offers some of the best water protection, and if used year-round, that high efficacy rating means you get the most light per watt. If you're seeing a price above $160, think seriously before buying. I personally think $180 is just too much. On the other hand, the TS1000 is the second most expensive light in our lineup, but it has much more output running at the full 150 watts. The efficacy isn't the highest, but 2.2 is good. And with that dimmer, you could run it at 100 watts while still having excellent light levels. To help with heat dissipation, the driver block is easy to remove with plenty of cabling. Remember though, with that exposed power connector, it's not waterproof. And with unbranded diodes, we can't project their lifespan or lumen maintenance. And it makes it easy for Mars Hydro to change the configuration without ever telling us. So who knows what they'll use on the next run? Unlike the 1000, the TS600 just isn't impressive. No test reports, but it likely has the lowest PPF and PPE. As a stripped-down model, it's cheap, but it's also cheaply made with a low power factor. I see no reason to waste your money on it unless you see it for $80 or less. Spider Farmer's SF1000D wasn't much better. Besides missing the dimmer, its light levels are much lower than the SF1000. Different diodes and very different driver leave much to be desired. If you're on a tight budget, it might be an okay option at $90. But for just $10 more, the PB1000 is the clear winner. Maxsisun has built a solid, affordable product. The Samsung diodes are a little less efficient than 301Bs, but it still has the best efficacy at the $100 range. It's missing devoted IR diodes, but compared to the other budget lights, the spectral difference is minimal. The light has better water protection though. It has an excellent power factor, and although it doesn't have a dimmer box, technically you could dim it if you wanted. When you choose a product, you're also selecting a brand. Out of the 4 companies I contacted, how does each stack up? Mars Hydro was the least helpful. Yes, I got a report, but it was obsolete. The TS600 had no data, just inflated specs. Their unwillingness to correct errors and provide updated tests breeds distrust. Viper Spectra has decent products, but initially they couldn't produce tests to back their specs. As this review entered production, I finally got a test report, a step in the right direction, but it proved they had inflated their PPE. Fortunately, they've told me they intend to fix their data, so I hope I can recommend them in the future. Spider Farmer was more reliable in this regard. They do actively test their products. Some of their specs were off, but they responded, fixing them. Maxsisun's products are well designed, and they've been proactive in acquiring and integrating Sphere. They were fast in fixing their numbers, being the first company to do so. And that takes courage, as everyone else pushes fake numbers. My goal is to get all of these companies to provide honest specs. Nobody likes to be tricked or lied to. I think I've managed to make a dent, getting things moving in the right direction. You can do your part by holding sellers to a higher standard and asking for those test reports. And if you're a reviewer, push for test reports. Don't compromise, no matter how many free lights get dangled in front of you. Looking at the actual lights in today's review, the 4 that I recommend are the SF, PB, MF, and TS1000. Each has distinct advantages, and any one of them might work for you. But price is a real factor. If you see inflated prices, it might be worth selecting an alternative. Or just wait until those prices come back down. Hopefully, this info has given you some objective data in selecting your grow light. Please check the description for links, and you can support my channel by liking and subscribing. I hope you have a great growing season, and I'd like to wish you happy gardening. Hello, yes, I was calling about my past due electric bill. Would you accept an LED grow light as payment? Maybe give me a partial credit or something?
No. You'll have to pay with real money, like everyone else.
I see.